Okay, so we're going to be starting a unit on circles. There's a lot of vocabulary involved with circles, so we're going to go over that in this video. Be sure you learn all these terms because we're going to be using them a lot later. The first question we have to ask is, what is a circle? Seems like a pretty simple answer, but it has a definite definition. A circle is simply this. You take any point on a flat surface, and a circle is the collection of all points that are equidistant on the same flat surface or the plane from your point. The next definition we're going to go over is a chord. A chord is very easy to understand. A chord is simply a line segment whose endpoints are on the circle. Here, our chord would be AB. And of course, we should have a segment bar over the letters AB. Next, we're going to talk about interior points and exterior points. These are pretty self-explanatory. Interior points are any points that are closer to the center than any point on the circle. Exterior points are any points on the outside of the circle. They would all be further away from the center of the circle than the circle itself. The diameter. The diameter of a circle is simply a chord that passes through the center of a circle. It's the longest chord in a circle. It's really important to note here that there is not just one diameter. There can be multiple diameters that pass through the center of a circle. A tangent. Now this is probably a new term for some of y'all. A tangent is a line that intersects a circle at exactly one point. We say it quote unquote touches the circle. But it's really key here that it would touch only at one point. Here the line would be AB, and it would be touching the circle at only point A. A secant is a line also, but it touches a circle at 2 points. When we say instead of just touching the circle, it goes through the circle. A point of tangency. A point of tangency is the point in which the circle and the tangent intersect. Here the point of tangency would be the point M. Tangent circles. Circles can be tangent also. It means they touch at only one point. In both of these examples here, the point of tangency is the point M. One important thing, though, is that the circles have to be coplanar. They both have to be on the same plane. Now, you'll notice that there's two different examples here. There's the example here and the example here. They're very similar, but they're a little bit different. These are said to be externally tangent circles. Externally tangent circles, the two circles are outside of each other. These are said to be internally tangent circles. One of the circles is inside the other circle. We also have common tangents. These are lines or segments that is tangent to two coplanar circles. Here, these are said to be common external tangents because the lines are on the outside of the circles. Here, these are common internal tangents. They are internal because they are between the centers. of the circles. Here they're external because they are out, they do not pass between the two centers of the circles. Congruent circles are two or more circles that have the same length of the radii. I need to correct my spelling there. Of radii. That means that all the points of each circle is the same distance from the center. The circle on the left has a diameter of 28, which means the radius would be 14. Here the radius is 14. Since both radiuses are 14, the circles are congruent. Concentric circles are simply circles that have the same center. If we alternated the colors, it would almost look like a bullseye. An inscribed polygon. An inscribed polygon is a polygon inside a circle. All the vertices are on the circle. In this example, we have a pentagon that is an inscribed polygon. It is inside the circle. Pentagons are not the only thing that can be inscribed in a circle. Squares could also be inscribed on a circle. Or any other polygon can be inscribed inside of a circle, if we can get this picture to move as such. A circumscribed polygon is a polygon outside of a circle. It goes around. Circum is a Latin word which means around. This one goes around the circle. Here, all the sides of the polygon touch the circle. Any regular polygon can be circumscribed on a circle. Properties of tangents theorem. We will prove these theorems later, but we're going to learn what they are first. Number one, in a plane, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. This is the line that is tangent to the circle. This is the radius drawn from the center of the circle to the point of tangency. These segments will always meet perpendicular. The converse is also true. In a plane, if a line is perpendicular to a radius of a circle at its endpoint on the circle, then the line is tangent to the circle. And the third property of tangent theorem, if two segments from the same exterior point are tangent to the circle, then they are congruent. Here we have the point M that is on an exterior point to the circle. It forms two segments or two lines that are tangent to the circle. The segments ML and MG originate from the same exterior point. G and L are both points of tangency. Therefore, segment ML and segment MG would be congruent.